Today we're going to talk about, we'll move on and we'll talk about archaeological excavation. So survey is where you go and find archaeological sites, and excavation is where you potentially dig them up. Those are the two kinds of field work that most archaeologists do. When I say potentially dig them up, the archaeological record is finite, and it's a general principle in archaeology that we only excavate if we have a good reason to do so. We have to have a good plan. Usually it requires money, and you have to ask somebody for that funding. So you have to have a well-developed plan of how you're going to excavate the site and why you're going to excavate it. We'll cover some of that as we move along, but we'll start off, we'll follow the textbook as we begin. The key thing about excavating is that you have to know where everything is as you're excavating. We call this its provenience. It's the location relative to a system of spatial data collection is the most important thing about an artifact. I like to define provenience as a artifact's sort of three-dimensional position in space. But obviously it's relative to other things. Typically you'll set up a site datum, a central location where you'll record all of your measurements from. And before you can begin excavating, you have to set up a single point on the site called the site datum. And so therefore anything you remove or find, everything that you do on an archaeological site from that point that you set that datum forward, you have to record how and where it is in relationship to that datum. Because archaeological data, just a bag of archaeological data is not terribly useful. It's not completely useless, but if you don't understand something's context, it's very difficult to make sense of it. We define context as the relationship of an artifact, ecofact, or feature to other artifacts, features, and geological strata in the site. An artifact is any object that we find that was either manufactured or used by human beings. It can also be a broken or incomplete object. It can be the pieces of broken objects. It can be the manufacturing waste that was produced while manufacturing an object. If it had anything to do with a person, and if it had anything to do with the person as it was created, we call it an artifact. I realize that I may have used the term before in this class, and I use it kind of loosely, but I talk about artifacts because it's really a very, very common word in archaeology. When my first excavation was in San Diego, well, not counting the field school I went on in Nevada, which I mentioned last week, but the first excavation where I knew what I was doing was in San Diego, and I can recall we found over 1,000 artifacts on our first day. We were excavating a site where probably stone tools were being manufactured because there was stone chips everywhere that all were part of the manufacturing process when you're manufacturing a stone tool. Unfortunately, we won't get to do it, but it'd be kind of fun to sit outside and make stone tools. I haven't got the raw materials. If any of you live on a ranch in Central Texas and want to bring us some flint or chert or some good material, we could all sit outside one day and try to make arrowheads. But you could see it makes a lot of waste. There's a tremendous amount of waste. Just making one stone tool could create hundreds or thousands of flakes, which we would call artifacts. If a pot breaks, a clay pot breaks into 50 pieces, so those are 50 artifacts. All right, just keep that in mind. Now the term ecofact is used here as well. An ecofact is a term that I almost never use in the field. I only see it used in textbooks. I tend to refer to them as organic artifacts, but any kind of ecological item that you find that provides evidence or data that can help understand the people living there could be an ecofact. And this could be, for example, pollen. You find pollen at the site, and you might want to try to reconstruct what the vegetation was like when people were living there. And the pollen in the soil profile, it would be an ecofact. Charcoal that you find from a fire, those are ecofacts. Like I said, I tend not to use the term. I just refer to those things as, I refer to them as artifacts also, but I'll try not to get funny on you on the test. I'll tell you what, I just won't use the term ecofact on the test. Right. So knowing where something came from is very important for us to be able to make any sense of the archaeological site. We talked about that with radiocarbon dating in particular. If you find charcoal, you can't usually date the artifacts. You have to date the layers around the artifacts. So context is everything. An example of how excavation can be used to solve a problem is the Folsom Site. For a very long time, up into the 40s and 50s, archaeologists didn't really think humans had been in the New World much longer than about 4 or 5,000 years. And the reason being is that there simply was no evidence for it. They hadn't found any archaeological sites where human beings were associated, for example, with extinct animals that might have lived 7 to 10,000 years ago. The Pleistocene is this period in time from 1.8 million years ago to about 10,000 years ago. We sometimes call the Pleistocene the Ice Age. The Ice Age is not a scientific term, and it's in some ways inaccurate because temperature during the Pleistocene is not always cold. It fluctuates from hot or from warm to cold and warm and cold. It's actually a period of fluctuating temperature. But it's characterized, if you will, by these massive episodes of glaciation. Ice tends to form in the northern latitudes and then grow and extend and push down into continental United States, parts of Europe and whatnot. The ice sheets and the glaciers hold so much water that sea levels end up dropping during the Pleistocene. The sea levels along the coast of, the sea levels may have dropped 1 to 300 feet in the last glacial episode. Now, if you drop the sea level 1 to 300 feet here in Texas, well, in the Gulf of Mexico, what do you get? Anybody ever been out on the Gulf? How deep is the water in the Gulf? Not very, right off the coast anyway. It is over 1 to 300 feet. But think about it for a second. If there were people living here at that time, and they were living along the coastline, where would those archaeological sites be now? They'd be way out in the Gulf, probably ruined and destroyed by wave action as the sea levels were rising. If you look at data produced by oceanographers who are mapping the seafloor, you can actually see where, for example, the Brazos River would have continued on its way down. You can look at the seafloor maps, and you can see where the old coastline might have been. That's where you'd want to look for archaeological sites. For this reason, they're finding the oldest archaeological sites has been a little bit problematic, because if people migrated to the United States, or to the New World, I should say, from, say, the Old World via a land bridge that was created also during the sea level lowering between Asia and, say, the area where Alaska is now, they would have come along the coastline, and all that coastline is submerged now. So with lower sea levels, you have a clear walkway between Alaska and Siberia, and it's at that time that we believe people first came over. We'll talk more about that later, but that's the theory nowadays. So nowadays, people think humans got here a lot older than, say, 4,000 or 5,000 years ago, but a lot of that's because of the Folsom Site. The Folsom Site was discovered in the 1900s, early 1900s, and they found this. If you can see the lower right, let me take a look at this lower right. There's a bison skull. In fact, this site turned out to be a bison kill site. This is located in New Mexico. They eventually found hundreds of bison, and they found, with those bison, they found that they'd been cut. So there's cut marks, butcher marks, and they found lots of remains of stone tools. Now, bison, there's two kinds of bison, really. There's bison, which is what we have today running around in North Dakota and whatnot. And then you have bison antiquus. Bison antiquus is a giant bison. It's much larger than what we have today, and they're extinct. And this is what they were finding. So they began finding extinct bison along with human-made artifacts. And I haven't got a close-up of this, but this is a stone point. It says here, the caption says, a fluted Folsom spear point lying between the ribs of an extinct species of bison at the Folsom Site. The type of point that they were using, I call it a projectile point. I call it a projectile point, which is a generic term for any kind of a point. An arrowhead is a type of projectile point. A spear point is a type of projectile point. This Folsom point, that I'm looking there, it doesn't have a scale. I have to criticize this author for not putting a scale in this picture. That looks like it's broken, to be honest with you. It looks like it's only about 3 inches long or so, depending on how big those ribs are. Folsom points could be 6, 8, 9 inches long, but they're characterized by having a long, we call it a flute. It's a long divot that runs down the entire axis of the flake. So it's thinned along the middle. And it's this thinning along the middle that allows it, potentially, the idea is that it could be hafted. That could be stuck into a split on a spear, and then you would tie the cord or whatever you had, leather straps or cordage, around your spear, and it would create a spear point. Could also be a knife point. By the way, a spear point and a knife and a spear would have different wear patterns that you could look at forensically. Spear points tend to be used for jabbing. Knives tend to be used more for cutting. It creates different wear patterns. So that could be figured out. We'll take their word for it right now that it's a spear point. Now these objects were found right where when you find objects like this right where they are, we call that in situ. The term in situ is used a lot. If we were going to go on a field school right now, I would say, look, your goal is to find all of your objects in situ, from Latin, meaning in position, the place where an artifact, ecofact, or feature was found during survey or excavation. It does not mean the place where it was left by the people who used it or discarded it. as you know from our discussion on site formation processes, objects can move around. Now, if we're fortunate and there hasn't been a lot of disturbance at this archaeological site, then the association between the spear point and the extinct bison remains means something. In this case, the archaeologists argued that it confirmed the presence of people in the Americas since at least the end of the Pleistocene, some 10,000 years ago, which is when these bison were running around. For a long time, these guys were thought of as being the oldest inhabitants of North America. And then you had another set of archaeological features that were found with mammoth remains in a slightly different form of tool type, and they were called clovis. And for as long as I've been an archaeologist, clovis has been thought of as being the oldest cultural group in the New World. Again, in New Mexico and Arizona, the clovis culture seems to be from about 10 to 11 to 12,000 years ago. And now archaeologists today are trying to figure out if maybe there's an earlier component. It's still hotly debated as to whether there is an earlier, what they call pre-Clovis component. And part of the problem is that they're believed to have come along the coastline, and so all of the sites where they would have existed along the west coast of North America are underwater at this point. Well, those bones were well preserved, fortunately. And preservation is obviously something that all archaeologists want, but organic materials just simply don't survive very well. The stone survives well, pottery survives pretty well, but wood and bone and food remains, these things you almost never find at an archaeological site. So we want to have a little discussion here on what are the factors that help preserve objects and what kind of factors work against it. The basic thing, the basic sort of environmental variable, I guess, that makes the biggest difference on preservation is changes in temperature and humidity. Or really, I should maybe say temperature and water content. Other factors would be oxygen. Let's just work with those three. So temperatures, hot and cold. The thing about temperature is that it's directly related to humidity. So we can forget about temperature for just a moment. No, I won't forget about it. But I will say this, that obviously if you have freezing temperatures, that could be good for preservation. A lot of you probably use your freezer to put things that are going to spoil in there for that very reason, that it slows down the process of degradation. Heat, on the other hand, doesn't by itself preserve anything other than the fact that it might dry out water and dry something. But in both the cases of something that's, say, air dried because of hot weather or freeze dried because of cold weather, in both cases, in order for it to stay preserved, you have to have constant conditions. If you have a freeze thaw, freeze thaw, freeze thaw, that's not good for preservation. One of the things that happens as water gets into something is water expands and contracts when it is frozen. expands when it's frozen, contracts when it's unfrozen. And this constant action, if you have water in something, typically organic materials have water in them, and it freezes, the damage is done. Okay, it's done. But now if it stays frozen, it's probably still going to be all right. It's damaged, but it's going to be something you can come back and get to. But if it thaws out and then freezes on an annual basis, then essentially you have this slow wedging in of all of its pores and expansion, and it will just tear an object apart after year. So even though heat and cold are factors, it's really the constancy of the environment which allows something to be preserved. So if you could find an environment that is always hot or always cold, you're in good shape. When it comes to the water content, again, it's really about constancy. If you have something that's waterlogged and it's always waterlogged, then you might be all right with that. And if you have something that's dry and it's always dry, then you might have some preservation there. But if you have a constant situation where you're going to have drying and wetting and drying and wetting, the same kind of thing happens because organic objects, soak in water so they expand, and then when they dry, they shrink, and this makes things weaker and brittle over time, and eventually you don't have very good preservation. Finally, I mentioned oxygen. Oxygen is required by most microorganisms to live. Some kind of oxygen content. If you can get into a situation where there's no oxygen, you have a really good chance for preservation. There's a couple of circumstances under which you can get objects into a no oxygen environment. One is if they're rapidly buried by a non-porous sediment like clay. If you can bury something in clay, you're essentially sealing it like in a vacuum sealed bag. This is why sometimes when you can have an object that was deposited on the seafloor, and if it was rapidly buried in mud, you can have really good preservation. This happened with a Swedish ship called the Vasa. And it'd be cool. I should put up some pictures. I'll put up some pictures on the website. The Vasa. It's an amazing ship. It's in a museum now. It was made in the 1500s, late 1500s. And when they pulled it out of the mud at the bottom of Stockholm Harbor, it looked almost like it had just fallen in there. I mean, it was literally like a ghost ship had appeared in Stockholm Harbor. It was a massive, ornate warship that was intended to be the admiral's ship on the fleet. But they made a mistake in the engineering process. They made the gun ports too low, and they were all open when it sailed, and it launched, and it immediately began filling up with water and sunk to the bottom of the harbor right as it was launched. Somebody probably lost their job. Do you think? Maybe more. Anyway, but it was buried rapidly in mud, so it was very well preserved. Another type of low oxygen environment is in, say, a marsh or a bog where you have stagnant water. If you have stagnant water, just water that's not moving, what happens is the organisms consume all the oxygen at the bottom. And once the oxygen is consumed, if there's no water movement, you essentially have a condition where there's no oxygen at the bottom of this environment. If any of you have ever gotten into some mud that was stagnant and you smelled this horrible stench, that's a product of this. That's an anaerobic condition that would be good for preservation. Well, I'll give you a few examples. Here's organic materials, a duck decoy from Lovelock Cave, Nevada. This is a dry cave. Dry caves are fantastic. Out west, you have two conditions. Generally speaking, you have warmth, but it's not warm year-round, but it is dry year-round. And some of these caves are so dry that these objects have not experienced changes in humidity and temperature. So even when in humidity, and they haven't shrunk and swollen because it's always dry. Because when it gets cold at Lovelock Cave, it was still arid. Consequently, with very little water content in the object, even if it were to freeze, you wouldn't have any damage because there's no water in it to expand. So dry caves provide really good points of preservation. You may have heard in South America there's some mummies that have been found in South American caves. It's a very similar condition. These mummies were made not, so to speak, by people. They weren't mummified by, like the Egyptians would mummify people. These folks were simply buried in their normal burial fashion, and they became mummified by their exposure in this cave. There's dry caves even down here in Texas. There's a whole bunch of dry caves, Hines Cave, and a few others down between Del Rio and as you move up towards Big Bend. There's a lot of caves in that part of Texas that have excellent preservation. Some of those caves even have rock art paintings in them that have preserved for a very long time. So dry is very good. Another famous example here is Ozette. This is a coastal site in Washington that was buried in mud, possibly from a landslide, possibly from, well, it was from a landslide, but possibly due to a volcanic eruption or whatnot. This site was buried in mud, and they had all of the wood from the houses. The house floors were preserved. The thing about it is, though, the mud didn't bury, it wasn't like 15 feet deep. The mud was just, a couple of feet deep. So you had structures and things that were sticking out of the top after it was buried, and none of that is preserved. None of the top half of things are preserved, but you have the lower sections, the floor plans are all preserved. You have whale bones and jewelry. There's just excellent preservation. If you ever get a chance to go up to the museum there in Washington, pretty sure it's in Seattle now, where the items are, but they could be down at the reservation. I'm not sure, but Ozette is a real famous site. It wasn't that old, so it didn't do a lot for learning about the early history of humankind in North America, but it did have a lot of information on the cultures of the Pacific Northwest from about 3,000 years ago. And another example, one of my favorite examples, Otzi the Iceman, discovered in, I want to say Switzerland, but in reality he was discovered in this part of the Alps that is so remote that it's claimed by 3 different nations. It's claimed by Switzerland, Italy, and starts with an A, Austria, right? Austria, Italy, and Switzerland. They all claimed him. The Swiss are the ones that found him. He was initially thought to be a hiker who was just lost in the snow, because they find bodies up there in the snow all the time. But they found, it's very much like Kennewick Man, they found this guy had a spear point or an arrowhead embedded in him. He also had copper tools, some stone tools, bow and arrow. His clothing was preserved, to some extent. He had tattoos on his body. They radiocarbon dated him. He's about 5,000 something years old. So he's a very interesting character. He apparently was walking across the Alps when he died. He's got an interesting story. Maybe we'll watch a movie on him. Trying to figure out what happened to him. A lot of people think he was murdered. Anyway, there's a lot to learn from this guy. He was preserved by being frozen and constantly frozen up there at that point in the Alps. He was in a glacial environment, which means it never thaws out. So that's why he was preserved. What do I think happened to him? I don't know. I can't speculate.
So his condition basically very similar to like the bog bodies Germany and Netherlands.
Bog bodies, which are found throughout northern Europe, are well preserved for two reasons. One is that they are in an anaerobic environment. They're in the bottom of these bogs, and these bogs are very low oxygen content. And then secondly, because the peat bogs produce an effect which essentially cures the body, a tannic acid that tans the body, just like you would tan a hide. The same, but naturally, it naturally tans them and preserves them. And those combinations make them preserved. Otzi here is preserved not by either of those processes. He was literally freeze-dried. So he looks a little bit similar in the sense that he's got this brown coloration and a funny look on his face. But bog bodies are actually much better preserved than him. It might be kind of fun to look at some bog bodies in the class and see what we can learn from them. I usually would save them for my old world archaeology class, and this guy too, for that matter. But there's a lot of bodies that are known in Europe, very few in North America, even though we have some conditions that would preserve them in North America. You have swamps and bogs throughout the South. I suspect they're there. We just don't know how to find them because we don't tend to do anything with our swamps and bogs other than fill them in. In Europe, the bogs are used. What happens in Europe is they get filled up with peat, and the peat is then useful to Europeans, or has been useful to Europeans, and they would cut this peat and use it for various purposes. And the peat cutters would find these bodies as they were mining the peat. So there's probably a lot of bodies in the United States in our bogs, some of them not so old. I heard that they found some bodies in a cenote. You know what a cenote is? It's a form of spring that you find mostly south of here in these limestone type areas. You can have, if you have a spring, the spring can over time develop a giant hole going straight down. Anyway, some of these cenotes are filled with water, and sometimes divers will go down diving in these things. And at some point, somebody found a bunch of skulls along a ledge down underwater in one of these cenotes. And when they moved the skulls, they literally, brains were falling out, and they turned out to be very well preserved heads. Pretty sure that was in Florida. And they were old. They weren't somebody's recent heads. So you can have these things. It's pretty rare. Well, most archaeological sites aren't in this category. They don't have good preservation. If you want to be an archaeologist and specialize in excavating really great archaeological sites, these are the kinds of things you're going to have to look for. There actually are plenty of dry caves left to be excavated in North America. But finding something like Iceman, Otzi, or a bog body is, 1 million to 1. You just have to be fortuitous to get that one. Let's start our discussion of principles of excavation. Most of the time, we are going to be trying to grid off our archaeological site into 1 meter squares. We use metric in archaeology by convention, just by scientific, by agreement. We use metric. And we tend to think in 1 meter squares. 1 meter squares because of the contents. If you dig everything in equal volume, then you can. It's easier to compare one location with the next. A test excavation is when you dig typically when you dig a single square, a 1 by 1, and usually the purpose is to determine the potential for answering a research question. So you might go out and an archaeologist might say test, what they call test an archaeological site, test it for significance. They'll go out to the archaeological site, they'll dig 2 or 3 test pits, and they dig these straight down in levels. So they'll dig 10 centimeters, for example. Levels are covered on the next slide, but I'll just tell you right now. You dig, for example, you dig 10 centimeters, 1/10 of a meter. Why 10 centimeters? Again, by agreement. You dig no more than 10 centimeters and then you stop. So you have 1/10 of a square meter, essentially, when you're done excavating your first level. You try to find everything in situ. That's your goal. But you don't find everything in situ. A lot of the stuff you find after you take the dirt out and you sift through it a second time is when you find it. So the reason they go in levels is so that at least you know within 1/10 of a square meter, essentially, at least you have that level of provenience. So you may not know exactly where something comes from if you don't find it in situ, but you know approximately where it came from. So that's kind of the way they do it. But let me just continue on with this slide. So you dig in 1 meter squares, you record the X, Y, and Z axis because that is the provenience. Vertical provenience is measured relative to the ground surface. Now, I will say that that is what the author here is telling you that he does, or they do. That's how they do it. They have their excavators record the Z in relationship to the ground surface. But a lot of archaeologists don't do that. For example, they'll tell the excavators that your ground surface is, say, 30 centimeters below datum level. And so when they record their data from their excavation, they'll add 30 centimeters to whatever the depth is. And so they'll be recording depth below datum. Remember I mentioned the datum. The datum is this place, this point that you've established on the site from which all your measurements are supposed to be taking place. So whether or not an excavator with their little test excavation pit, whether they record from the ground surface or from the datum, I guess is inconsequential so long as they can ultimately trace it back to the datum. Setting up your datum actually could be one of the most challenging aspects of archaeology, and it's something that isn't taught for whatever reason. When you get out to an archaeological site and you want to establish your datum, it's a critical moment when you decide which way is north. You have a compass maybe, right? And you say, okay, well, I'm going to use magnetic north. I'm just going to use my compass. Well, if your compass may or may not be that accurate, you could use a GPS, but your GPS is hard to do. You'd have to it may not be accurate enough to get you a due north. And the problem is the whole point behind recording your establishing your grid, your 1 meter grid over the site. And the whole point, well, there's 2 points. One is so you know exactly where everything came from. But secondly, if anyone else were ever to come back to the archaeological site, they want to know where you were. Where did you excavate? And so you have to be able to, you need to be able to use the same north that somebody who comes by in 30 years is going to do. I don't know if you know this, but magnetic north moves around a little bit over time. And so most geographers prefer to use true north, which is where you subtract a declination. Anyway, it gets complicated. So we excavate, the 10 centimeter level that I told you was what you call an arbitrary level. And it's a horizontal level, meaning you're digging 10 centimeters down, then you make the bottom level with the top, with the surface, at the ground surface. what I described to you was called a arbitrary level. It's arbitrary. I picked that number 10 centimeters out of not of thin air because it's pretty much standardized across the discipline that you'll dig in 10 centimeter levels. Or really, as a project archaeologist, you could tell your excavators to dig in any increment. But 10 centimeters would be the max. Now, if you happen to know the stratigraphy of the site, I mean, if you have a layer of sand and then it's right over a layer of clay, you could tell your excavators, excavate in natural levels. A natural level then is one where the stratigraphy is well defined and you simply dig one stratum, if you will. You excavate the contents of an entire stratum. This might be preferable. You definitely don't want to mix strata together. As we've discussed in the geoarchaeology section, your stratigraphy is very important, and you want to be able to find only the things that are, you want to cluster everything from the same strata together, because a strata represents either a single event or a range of time. And whenever you cross strata, you could be mixing two time groups together. So if I tell you to dig in 10 centimeter arbitrary levels, and your arbitrary level cross cuts two strata, then you're going to be mixing stuff together. So if you notice, it would be preferable to dig in natural levels. That way you don't mix objects from different time periods together unknowingly. But it's hard because when you first excavate, you don't know anything about what you're going to find. You don't know what it's like underground. You don't know how old anything is. You don't even know if anything's there. So it's hard to predict and say, hey guys, make sure you dig in natural levels, because you'd have no idea if there even are any natural levels. It could just be a single soil profile. So you always start off with arbitrary levels for practical reasons. Basic vertical subdivision of an excavation square. Used only when recognizable natural strata are lacking and when natural strata are more than 10 centimeters. In other words, you only want to dig 10 centimeters in any case. Because again, when you find stuff in your screen, when you take the dirt out of the unit and you have your screener screening it a second time, if they find something, you want to be able to say about where something came from. With that, I think I'm out of time. It's 1:30, so we'll go ahead and end there. I'll finish this up on Wednesday.